Hello and welcome back, dear students. This is Sanjeev Century from St. Joseph School. Hope you all are fine at your home and maintaining social distance. So, in the spare time, let's utilize and continue with the video. In my last class, I taught you something about types of matrix and problems related with equal matrix, and in that part I gave you some work as home assignment. Hope you all have done that, and today's video is based on the solution of that home assignment that I had given you. So today I am going to give you the solution and you can correct it at your home. The first question was like this: state the types of matrix. There were 8 questions, and in first question there is only one row and 3 columns, one row and 3 columns. So what type of matrix is it? Yes, it is row matrix. It is what? Row matrix. Its number of row and number of column are not equal. It can also be said as rectangular matrix, but the best answer for this question is row matrix. Okay, and the second one, see, yeah, the order of the given matrix is 3 by 1. There are 3 row, 1, 2, 3 and 1 column. So its order is 3 by 1. So it says that it is column matrix. And it can also be said as rectangular matrix, but the last option, it is the best answer for this question is column matrix. Okay, now let's come to question number C. Observe it carefully. See, all the elements are not 0 and the diagonal elements, observe it, they are also not constant and they are not equal, and 0 is there. So the best answer for this question is square matrix. It is what? Square matrix, because its number of row and number of column are equal. Number of row and number of column are equal. That's why it is a square matrix. Okay, now question number D. See, all the elements are 0. So that's why it is null matrix or zero matrix. Question number E now. So here in question number E, number of row is equal to number of column, but the elements in main diagonal are non-zero, whereas other elements are 0. That's why it is a diagonal matrix. Square matrix having non-zero main diagonals and other elements 0. Now question number F. In question number F, it is 3 by 3 matrix. All the elements except main diagonals are 0. See, other elements except main diagonals are 0, and in the main diagonals all the numbers are 1. That's why it is a unit matrix. unit matrix or identity matrix? Now question number G. See, in question number G, elements above the main diagonal are 0. Elements above the main diagonals are 0. That's why it is a lower triangular matrix. Last question, question number H. Observe carefully. See the elements. Here you'll see a pattern. See here. In this matrix, A 1 2 is equals to minus 3, and A 2 1 is equals to 3. See the pattern. In this pattern you'll see that A 1 2 is equals to minus A 2 1, isn't it? A 1 2 is equals to minus A 2 1. This pattern was seen in which matrix? Yes, skew symmetric matrix. This is not valid for only one element. This is, you can see, for example, another part is A 1 3 is equals to minus 2 and A 3 1 is equals to 2. See here, A 1 3 is equals to minus A 3 1. Is it or not? So, and last one is A 2 3 is equals to minus 8. A 3 2 is equals to 8, and A 2 3 is equals to minus A 3 2, which means it is a skew symmetric matrix. This is the solution of the first question. Now let's move on to the second question, which was related with the equal matrices. The question was like this: find the value of x, y and z from the following cases. And the question number A was like this. It is very simple and let's do it. The first thing that we have to do is to equate the corresponding elements. And what are corresponding elements? I have explained that in my previous video as well. See, this is element A11 and another matrix. This is also element of A11, element at A11. 2 is equals to 2, 4 is equals to 4 and 6 is equals to Z. So this is what corresponding elements. So now writing equating the corresponding elements of equal matrices we get, see, from alphabetical order, x is equals to 5, y is equals to 3 and z is equals to 6. Okay, thus the above is the required solution. Let's move on to the second question. Question number B. Again here doing the same thing, equating the corresponding elements of equal matrices, we get, here we don't get the value directly because there is combination of variable x minus y, 2x minus 3y. That's why first of all we have to find out the equation. So we get x minus y is equals to 3, equation 1, and 2x minus 3y is equals to 4, equation 2. Okay, this type of question you have done in mathematics. We have done this question in mathematics by elimination and substitution method, and here I am going to solve by substitution method. We can do it by elimination method as well. So for substitution method, I am going to take one equation, derive value of one variable in terms of other, and plot that value in another equation. Listen it very carefully because it is very important. I'll explain that again. Okay, so you have to find out the value of one variable from one equation. For example, if I'll take the value of x from equation 1, find out the value of x in terms of y from equation 1, then I'm going to plot that value of x in equation 2 to find the value of y. It is very important because if I'll find the value of x in terms of y from equation 1 and again plot that in equation 1, then that will give 0 answer. Both the sides will be 0 or constant. You will not get the value of x or y. So this is what you have to keep in mind. So I am going to take equation 1 from equation 1, x minus y is equals to 3, or x is equals to 3 plus y. Let's consider it as a equation number 3. Now plotting the value of x that we have derived from equation 1 in terms of y in equation 2. Now putting the value of x in equation 2. Equation 2 is 2x minus 3y is equals to 4, or 2, 3 plus y minus 3y is equals to 4. As I have already taught you that while placing the value of one variable in terms of other, we have to plot that within the bracket, okay, because that will help you to solve it properly. Otherwise you may do mistake. If you plot dot over here only, then you will multiply 2 with 3 but not to y, so that will cause mistake. So use of bracket that I have explained you in my class. Okay, 2 3s are 6 plus 2y, opening the bracket. Now solve it. Two y minus 3y is equals to minus y is equals to 4, or I need y positive, that's why I have placed y on another side. You know how to place variables or numbers from one side to another side. What happens? Yeah, sign changes. Okay. Now y is equals to 2. The value of y is 2. Then putting value of y in equation 3, we get equation 3 is x is equals to 3 plus y, isn't it? Or x is equals to 3 plus 2, therefore x is equals to 5. Thus x is equals to 5 and y is equals to 2 are the required solution. Okay, this was second question. Let's move on to the third question. The third question was like this, and the first step is same, equating the corresponding elements of equal matrices we get x plus y is equals to 6. X plus y is equals to 6. X into y is equals to 8. This is equation 1. Sorry, equation 2. So you can find out equation from equation 1 or equation 2. I am taking from equation 1. X plus y is equals to 6, or x is equals to 6 minus y, as y has gone to the another side of the is equals to. So this is equation now 3. Okay, putting value of x in equation 2, we get x y is equals to 8. This is equation 2, or x is equals to 6 minus y into y is equals to 8, or multiply, we'll get 6y minus y square is equals to 8, or taking all the variables on other side, y square minus 6y plus 8, or arranging now it is in quadratic form. The concept of solving quadratic equation by middle term formula, you have done that in quadratic equation, but I'll give a glimpse of that here. For that, we have to arrange the polynomials in ascending or descending order. After arranging that, here it has 3 terms. That's why we have to multiply the coefficient of first term with the last term. Here the coefficient is 1 multiplied by 1 to 8, it is 1 8 is 8. Now 8, take out its factor, 2 and 4, see 2 4s are 8. You have to arrange the factors. See, in the first attempt I have the answer luckily, but if you don't have sometime, then you have to take out all the factors and arrange them in such a way such that its sum or addition results the middle term. As for example, here 4 2s are 8, isn't it? And 4 plus 2 is equals to 6. It is what? 4 plus 2 is equal to 6. So the condition for middle term factorization comes here. Okay. So now we will do the same thing here. 6 is 4 plus 2 y plus 8 is equals to 0, or y square minus 4y minus plus minus 2y plus 8 is equals to 0, or now you have to take common from these two conjugative terms. Common from these first two term, y is left and minus 4 is left here. Let's taking common minus 2 from here, minus 2, then y from plus, if minus comes out then minus is left, because minus into minus is equals to plus. So now y minus 4 is equals to 0. See, from this portion and this portion you can take out y minus 4 common, and the left are y and minus 2 is equals to 0. So from this condition, either y minus 4 is equals to 0 or y minus 2 is equals to 0. These are the two conditions that will derive, isn't it, when they will come down the 0. So from here, therefore y is equals to 4. When y is equals to 4, when y is equals to 4, from equation 3, x is equals to 6 minus y, or x is equals to 6 minus 4, therefore x is equals to 2. From this portion, and here from this portion y is equals to 2. When y is equals to 2, from equation 3, x is equals to 6 minus y, or x is equals to 6 minus 2, therefore x is equals to 4. Thus x is equals to 2 comma y is equals to 4, or x is equals to 4 comma y is equals to 2 are the required solution. And the last question, this is the question solution of this question, question number C, and the last question was like this, very simple solution. We'll do the solution here. So first step is same for every question, equating the corresponding elements of equal matrices. We get, see, equating x plus 2 is equals to 5, equation 1. Then y minus 3 is equals to 2, equation 2, and z plus 4 is equals to 7, equation 3. These are the three conditions that we can derive from the above given condition. Now, from equation 1, x plus 2 is equals to 5, or x is equals to 5 minus 2, therefore x is equals to 3. From equation 2, that is y minus 3 is equals to 2, or y is equals to minus 3 goes other side, it will become plus 3, so therefore y is equals to 5. Third equation, from equation 3, z plus 4 is equals to 7, or z is equals to 7, this another side, so plus 4 minus 4, okay, change of sign, z is equals to 3. Thus x is equals to 3, y is equals to 5, and z is equals to 3 are the required values. Okay, this was the solution. Hope you all understood. Okay, and I'll be here with another video next time. Till then, take care, have a good time, be safe, and bye bye.